we have completed resolution of vector, application of resolution of vector, and we solved some numericals based on the resolution of vector. I think all of you must have seen my last videos, and if you have any doubts, write the comments into comment box. So anyway, today's topic is product of two vectors. Product of two vectors. Product of two vectors. There are two ways in which a vector can be multiplied by another vector. There are two ways. Okay, so one is dot product, which is known as scalar product. Another is cross product, that is known as vector product. So dot product or scalar product cross product or vector product. Vector product. In case of dot product, you give dot. In case of cross product, you will give cross. ये दोनों मैथ्स में गुना बोलते हैं, लेकिन फिजिक्स में ये साइन देंगे तो वो स्केलर क्वांटिटी हो जाएगा, ये साइन देंगे तो वेक्टर क्वांटिटी हो जाएगा. लेट अस डिस्कस वन बाय वन. फर्स्ट वन इज डॉट प्रोडक्ट. Okay, suppose A is a vector, B is another vector, and if you multiply both of them and there is a cosine, small angle between them, so A dot B is equal to a₃b cos theta. This is the formula, and you can write this one is A, this one is B vector cos theta. This is the formula to find the dot product of two vectors. How can you define? Dot product of two vectors may be defined as the product of the magnitude of two vectors and the smaller cosine angle between them. This is the definition of the dot product. Okay, then how can you geometrical representation of dot product. Suppose this is the one vector A, this is the another vector B, and theta is the smaller angle between them. Then you can write this one is A dot B, which is known as a₃b cos theta. Okay, a₃b cos theta. A, B and cos theta all are scalars, so they are dot product also scalar. Okay, A and B is a scalar quantity. Both A and B have direction, but their dot product has no direction. That's why it is a scalar quantity. A is a vector, B is a vector. Their product is a also vector, but there is no direction. That's why it is not vector. Dot product. Okay. While you are another point is a₃b cos theta. All are you will get scalar. You see. A scalar, this one mod means it is scalar, this one B means it is scalar, and theta means angle, it is a number, it is a scalar. So all things you are getting after result multiplying, it is a scalar. That's why dot product of two vectors is a scalar quantity. Geometrical interpretation of scalar product. Geometrical interpretation of scalar product. Geometrical interpretation of scalar product. What it is? How can suppose this one is one vector? Suppose it is A. Another one is B. Okay, vector. This is the small angle theta. Suppose it is O, it is P, it is Q. Okay, and you are drawing a projection from B to A, and this is B cos theta. It is one way in which you can interpret the scalar product. A is a vector, B is a vector, theta is the small angle between them. But same thing you take, it is a vector A, this is a, you give in name, suppose it is R. Another vector is b. Similar same case theta, and if you draw the projection from a to this one, it is also you will get this one you will get here from b to a, here from a to b. So it is a cos theta. What you are getting here, you are getting a dot b is equal to a b cos theta. Okay, how can you define this one? This one is a b cos theta, a b cos theta. Okay, if you will give the name some name you will give. Suppose it is or b cos theta, up to this one is b cos theta, it is a into or. So how can you define? It is the a into the magnitude of component of b, b cos theta, one component of b, another is b sin theta, we are not taking the b sin theta, another component of b cos theta here in the direction of a. Similarly, in this case, what you will getting? A dot b, it is a b cos theta. Okay, but what you are taking here? Here is b a cos theta. So just opposite, b a cos theta. Suppose you are taking o, it is b, it is q, q suppose it is r. So now it is suppose b into or. What you are getting? Similarly, b into the magnitude of one component of a cos theta in the direction of b. So one thing is, you remember, you are getting one here b cos theta is the projection of b onto a vector. Here the projection of a onto b vector. That means scalar product of two vectors. Geometrically, how can you say? So product of two vectors is equal to the product of a magnitude of one vector and the magnitude of the component of other vector in the direction of first vector. You listen, this one is important. A is a vector, b is a vector, there is a component b vector b cos theta. So that's why you are taking this one. It is the product of one vector and the product of another vector component in the direction of first vector. Suppose this one is first vector, this one is second vector. This way you can geometrically represent the scalar product of two vectors. Now properties. Before going to properties, we should know what are the common examples of dot product. We know dot product means scalar product. That means it produces scalar quantity. So what is the dot product of scalar quantity? Examples. Okay, and power. P is equal to W by T. Okay, W is equal to Fs by T. Then you are getting F is equal to S by T. Force and velocity. It is the dot product of two vectors. You are getting the power. That is also known as instantaneous power. Another example, if we take, I am erasing this one. Electric flux, magnetic flux. Also, electric flux phi E is equal to E, the electric field over the area. It is dot product scalar quantity. Magnetic flux, if we take phi B, electric flux, magnetic flux, B, magnetic field over area. These are the common examples of dot product of two vectors. Then we should know the important things. What are the main important properties of dot product? Okay, first one is, you know, dot product of two vector is commutative. Commutative means a dot b, a b cos theta, b dot a, b a cos theta. So a dot b is equal to b dot a. Then dot product of two vectors obey distributive law. That means they are distributing in nature. They are distributing over addition. How can you write? A dot b plus c, vector sign must give a vector dot b plus a vector dot c. This is the distributive. Second one. Third one, you will get when two vectors are perpendicular. Suppose A is a vector, B is a vector, repeating the same process. Two vectors are perpendicular to each other. Perpendicular to each other means theta 90 degree. So AB cos theta 90 degree, AB into 0, so 0. So dot product of two vectors when they are perpendicular to each other, you are getting the value 0. And dot product of equal vector theta is equal to 0. Suppose equal vector, you will take A, B, A is equal to B. That means A dot B is equal to AB cos theta. That means A into A cos theta means 0 degree. So it is 0 degree. So what you are getting? A square. Okay, you can write this one is A square. When dot product of two equal vectors, they multiply each other. So for you only remember for equal vector theta is equal to 0. So you are getting this value. But dot product of a parallel vector theta is equal to 0. Another point, theta is equal to 0 for parallel vector. So how much? AB cos theta, AB cos 0. So it is AB. Maximum value. But when two vectors are antiparallel, theta is equal to 180 degree. So antiparallel. So for antiparallel, A dot B is equal to AB cos 180. Cos 180 is minus 1. So it is minus AB, minimum value. This is the minimum value. In this way, you will get the values while you are taking the condition. Either it is parallel, antiparallel, equal. But important is that is scalar product or dot product of two similar base vector. What are the base vector? Base unit vector is known as I cap, J cap, K cap. I cap, J cap, K cap are the unit vectors along the axis x axis, y axis and z axis respectively. Similarly, if you take I dot I cap dot I cap, that means it is 1 into 1 cos 0. So it is 1. Same vector J, it is 1 into 1 cos 0, 1. Then K cap, 1 into 1 cos 0, so 1. That means you are getting I cap is equal to J cap is equal to K cap is equal to K cap is equal to 1. That means what you are getting, the scalar product of two similar base vectors is unit, but two different vectors. Suppose it is two different vectors. Another one is two different vectors. Two different vectors, I cap dot J cap, you will get 0. J cap, K cap, you will get 0. K cap dot I cap, you will get 0. So that means when scalar product of two different base vector, there is two different base vector, they are scalar product, A always gives 0. Okay. But while you are taking the two vectors, a vector, suppose a vector you will write ax I cap, ay j cap, az k cap. Another vector b vector is equal to bx I cap, by j cap, bz k cap. You can write their dot product, okay, in this manner. Always remember this one is. Can I erase? Okay. How can you find the angle? Suppose a vector, b vector, their dot product is a b cos theta. So how can you write? A dot b is equal to, you are writing a b cos theta. So how can you find the angle between them? So cos theta is equal to, just you tell cos theta is equal to vector a dot vector b mod a mod b, and in terms of rectangular component vector a vector b, it is ax. Okay, here you see this one is very interesting. This one mod x square plus ay square plus az square square root, then bx square plus by square plus bz square. In this way you will calculate the value of theta, cos theta. Okay, then can you prove scalar product of two vectors is commutative? Yes, you know scalar product of two vectors is commutative. Oh, but how it is? You see, let us see. One is this one. Suppose this is one vector, vector A. This is another vector, vector B. Theta is the angle between them, small angle. And for complete vector is always how much? 360 degree. So this much vector is 360 degree minus theta. So when you are taking this one, so you are writing a dot b, it is ab cos theta, equation 1. But while you are taking this one, a dot b, ab cos 360 degree minus theta. So you are getting also ba cos theta. So you take b dot a better. So b dot a, ba. So ba cos theta, equation 2. So from equation 1 and 2. So you what you are getting? You are getting ab is equal to ba. Okay. And in this way, I told you how can you multiply a dot b. Suppose here a is a vector in this way, b is a vector in this way, along x-axis, y-axis, z-axis. So you will get a dot b, you will get I dot I, here I dot I 1. So it is ax bx. देखो जब तीनों चीज को गुना करते हो ना, देखो हम बोल देते सीधा गुना, 6 को तीनों में गुना करते हो, 5 को तीनों में गुना करते हो, प्लेस देके यूनिट प्लेस, 10th प्लेस, 100 प्लेस, 4 में तीनों को गुना करते फिर जोड़ते हो, बस इसको सब में गुना करेंगे. जब सब में गुना करेंगे इसी का वैल्यू आएगा, ये सब कैंसिल हो जाएगा, इसका साथ ये जीरो हो गया. तो रह गया कितना? देखो बढ़िया से I डॉट I 1, तो ax bx मिला, फिर ax by कितना? 0, तो 0 हुआ. ax bz कितना? 0 कट गया. ay bx कितना? 0. तो ay by क्योंकि j का साथ j है, तो ay by, फिर az bz. Other vectors are valueless, means you are getting 0 because I dot j, I cap dot j cap, unit vector, two different unit vector always gives 0. So you are getting 0. This is about the dot product. Okay, let us solve one numerical for your better understanding. Can I erase? Okay. You see here. Numerical 1. Okay. Suppose question is find the angle between the vectors. A vector is given, B vector is given. Oh, A vector A is equal to, as per the question, I cap plus 2j cap minus k cap. B vector is equal to